Welcome to Math Mini Lessons. My name is Sarah, and in this video, we're going to break down the 2024 New York State exam. Normally, the state exam has 48 questions, but if you looked on different websites, you can't find all of them, so you get an incomplete. So I made a complete exam using all kinds of different questions that will mimic the 7th grade exam. If you would like a copy of the exam and you're a teacher, just reach out to us in the comments. You'll find my email. And you can talk to us in your school about getting copies, or if you're a kid who also wants to find a copy, just reach out and we'll see what we can do for you. But I wanted to get you as prepared as possible. So before we break this down, this test, 7th grade, you are allowed to use a scientific calculator, which I have digitally here on the right side of my screen. This test will take 2 days. Some kids this year in 2025 will take it on computer. Some will take it on paper. It's the school's choice. By next year, all 7th graders in 2026 will take the 7th grade New York State test on computers. So what I'm going to do today is we're going to break down the multiple choice questions on this video. There are 38 multiple choice questions. 32 are from day 1. And 6 will be on day 2. So this video is going to feel very long because I'm going to go through all 38 questions and show you how I can break them down. And then in my next video, I'm going to go and look specifically at the constructed response questions, which are the last 10 questions. And these are your 1, 2, and 3 point questions. And I'll show not only how to break them down, but how to also do them on the equation editor for kids who are doing them on computer. Okay, so we're going to jump right in. Besides the fact that we're using the TI-30, which is a scientific calculator, you're going to have a reference sheet like this. Even if you do it on computer, there's a tab for it. If you're doing it on paper, you can get it on paper. And you can see all the different conversions that you can get, all the different formulas that you're allowed to have for prisms as well as other figures. But there's not a lot of geometry on this test. I'll tell you that right now. There's a scale factor question here and there, but not a lot of other geometry problems, but they give you all of this information. All right, so let's jump in, and we're going to look at the first 2 multiple choice questions. And what I'm going to ask you to do is hit pause, try the 2 questions out, and then I'm going to show you the 2 answers. If you get them right, move on to the next chapter, hit fast forward, and go to questions 3 and 4. But if you want to see the breakdown, or you had an error and you want to see how I break it down, stay on. All right, and with that, let's get started. Questions 1 and 2, the answers are B and A. All right, so let's see if you're staying on. Let's go through number 1, which is an RP problem. A store sells packages of butter. The table shows the cost in dollars. What is the cost per package? That's what we need to find. Now, if I can use any of these rates, I always choose to find the simplest one, the most friendly of numbers to start off with. And because I want the cost per dollar, I'm going to put cost per package. That's the rate that I'm going to write. So my cost is $9.75 for 3 packs. So one way I can find the unit rate is to simply see this as a division problem. $9.75 divided by 3. And you would just do that. You can do it on your paper or do it with your calculator, and you'll get your answer, $3.25. Okay? So that's all I did here. Let me find a nice little spot for it. Boom, done. Another way you could do this is you could make a ratio table. And that means you can take any rate that's here and you're just going to fill it in. So let's say you had packages and cost, and you decided I have 4 packages that cost $13. I want to know how much 1 package is. And here I can use my cross multiplying to figure that out. So again, this is just another method, or I can use cross products. 13 times 1 is 13. 4 times a number is 4n. And now as an equation, this is something I can solve. 4 times a number equals 13. So I can divide both sides by 4. And a number is equal to 13. Let's clear this out. 13 divided by 4. I still get the same rate, 325. So what I like about this method is that it doesn't matter, again, what rate you choose. It doesn't even matter the order that you're putting it in, as long as you're filling it in and keeping like with like in the right rows. And then once you have the equation, you can solve. But either way will work. Use what works best for you. Now, here's the next one. If the expression below has a positive value, one inequality represents all the possible values of x in the expression negative 3x. So what do we know here? I have negative 3 times some number gives me a positive. So when you talk about integers, the only way a negative, what do I have to multiply a negative by to get a positive? A negative times a negative has to give me a positive. That's something we know from our integer work. So let's think about this. We're going to think about the number 0. So I have to multiply negative 3 by a negative number. I have to. And all my negative numbers live on this side. Here are all my negatives. Here are all my positives. So I do want all of these numbers here. Okay? So from 0, I want everything to the left. Now, do I want to include 0? Yes or no? I want everything to the left of 0, but what about 0? And if you're not sure, just multiply it and see. Negative 3 times 0 is just 0, which is not positive or negative. It's nothing. So I don't want to include 0. So I want everything less than 0. So how do I write that? I want x to be all numbers that are less than 0. And that's why the answer is A. All right, hit pause and jot this down into your notes. Let's look at 3, 4, and 5. The answers are D, A, and B. Check off in your work. And stay here if you need to go over any of them. The first one is order of operations, is one of our EE questions. And just by looking, I see a lot of fractions and decimals. So what I'm going to do is I'm going to rewrite this with all decimals. Because it'll make it easier for me to compute with my calculator. So let's rewrite this as 3 5/10 minus 9 75/100 divided by negative 2 5/10. Now, if you're not sure how to change like a half into a decimal, you can just rewrite it as division. It's just 1 divided by 2. And you can use your calculator for that. So if you do that, you'll get to 0.5. If you do 3 divided by 4, you'll also get 0.75. So that can be helpful to you. Okay. So let's now go into it using order of operations. I'm going to do my first 2 first. I'm going to do this part first. And you can use your calculator. 3 5/10 minus 9 75/100, and I know I'm going to get a negative number because 9 is way more than 3, and I'm going to get negative 6 25/100, and I'm going to divide this by negative 2 5/10. Now, just looking at this, I have a negative divided by a negative, so I already know my answer is going to be positive. So I'm eliminating A and D already. Okay, so now you have to. A quick mistake that a lot of kids make, sometimes they use the negative sign. They use the subtraction for a negative. Where it says answer, that's what that negative sign is. So you're going to have to hit second and then that little answer to get that negative part. Okay, so second. Oh, there it is. I just hit it. The little negative part. And now I have 6 and 25/100 divided by negative 2 5/10. Okay, there you go, 2.5. So even I made a mistake by hitting the negative first, the second first. I could just hit that little negative sign and it popped right out. But there's my answer. My answer was positive 2 5/10. Okay. Yeah, I'm not afraid of having mistakes here as well because we do learn from them. And that's the whole point with math. I can be upset, or I can just think for a minute and try and figure out, like, all right, where what do I do? How do I shift? And how do I change it to get to the number I want? All right, let's look at the next one. A farmer plants 4 rows of seedlings. The first 3 rows are equal in length, and the 4th row is 19 yards. The total length of all 4 is 61 yards. What is the length in yards of each of the 3 rows? Okay, so there are 4 rows. 3 of them are the same. I just don't know what they are. So I'm going to write that as 3x. But we know that the 4th row is 19. So 3x plus 19 is 61 yards. All right, so how do I figure out what that x is? This is written in a form ax plus b equals c form. So what I'm going to do here is I'm going to start by, I want to rebalance these scales. So I'm going to start by getting rid of this number, this 19. I want to take 19 off of both sides of the equation. So I'm going to do that with subtraction. When I do that here, I'm getting a 0 pair, which is what I want. I want that x to be as isolated as possible. And 61 minus 19, let's see, let's clear this out. 61 minus 19 is 42. Great. So now I know a number times 3 is 42. So what times 3 makes 42? I can figure that out by dividing by 3. And when you do that, x is equal to, and if you're unsure, again, use your calculator. You get 14, which is answer A. Okay, so the big key here is once you get something written in this form, something times x plus something gives you something else. I want to deal with this whole number first because I really want to get this by itself. Once I have it in this form, like whatever that answer is, then I can get the x by itself using division. Okay? All right, we're going to get more practice with this during this test. Let's move to the next one. On average, ocean temperatures around the world range from -2 degrees Celsius to 32 degrees Celsius. What is the difference between those two oceans? So we did a lot of this in 6th grade, so I have numbers that are greater than and less than 0. So I have -2 degrees and I have positive 32 degrees. I want to know the space between them from here to here, and also recognizing it's definitely going to be more than 32 because I'm 32 away from 0. So I like to use this because then I can see I have a distance of 2 here, I have a distance of 32 here, and so my total distance is 34 degrees. And because my distance has to be positive, I can use 34 degrees positive because I'm counting the number of units. I can't have negative space between them. And you can see the common mistake some kids will make is that they'll just subtract the 2 and get 30. But remember, if I only subtracted 30, I wouldn't even pass the 0. All right, hit pause and jot this down into your notes. Ooh, our first stats and data question. Let me clear off because I do work out some problems before I talk about them. So here I have what's called a box and whisker plot because you can see a box and you can see the whiskers. The whiskers tell me how my data goes from here to here. So like for this one over here, it goes from this number here all the way to this number here. Let's see, 5, 10, 15, 20, 25. So this would be from 185, because that's 185, to 230. And then these boxes tell me something about my quartiles, like my percentages. So the first 25% of kids of values come from here to here. My middle value is here, 75%, and all the way to 100%. So it kind of breaks it up into quarters. And you can see sometimes all the data is really close together, and sometimes they're really far apart. All right, whoops. Let's go in and answer this question. The answer for this one is D. So let's go into this one. A bowling team participates in a 2-day tournament and records the score for each team on both days. The scores for both days are represented in the box plots. I call it box and whisker plots, but they're called box plots. One conclusion can be drawn. So I have to go through these one by one to see whether or not all the information is true. So in the first one, it says the scores on Friday and Saturday have the same median. Okay, so my median is like that same 50%, that middle dash. And I can see that is not true. They do not have the same median. So because I disproved that first thing, I'm just going to cross it all out because everything has to be true. For the second one, the scores on Friday, the score on Friday has a greater median. Okay, that's true. Friday does have a greater median and a greater interquartile range. So what that means is from here to here is more than from here to here. Okay, so here it goes 5, 10, 15, 20. So my interquartile range for this first one is 25 because it goes from 200. Oh, wait, not 25. It goes from 200 to 5, 10, 15, 20. It goes 20. For this one here, it goes 5, 10, 15, 20. So this interquartile range is the same. It goes, and it kind of helps for me to tell you what those numbers are. So from 190 to 210. So yeah, 20. And then the other one went from 200 to 220. So 20. So the first one we knew was right. Friday is a greater median. But it says for this one, the interquartile range has a greater range on Saturday. That's not true. They have the same. So second thing isn't true. I can cross it out. With C, the scores on Friday have a greater interquartile range. We know that's not true. We just talked about that. Cross it out. And the last one, the score on Friday has a greater median. So yep, Friday has a greater median than Saturday. And both have the same quartile range. That is also true. They both have an interquartile range of 20. Okay, so the key for this one is to be able to identify what the median is. And the median is always going to be that line in the middle of the box. That's your median. That's like the 50%. The whole range is going to go the distance from here to here. That's your range. And your interquartile range is the distance from here, from one side of your box to the other. So use that to help you figure out your information. All right, hit pause and jot this down into your notes. Let's look at number 7 and 8. The answers are C and A. And let's start by going over them. Okay, with the first one, Mr. Moore collected data from his 6th grade class on how many minutes they studied for a test. The dot plot, different because that's dots, shows the number of minutes each student studied. Which statement about the distribution of the data is true? So I have to see which of these is true. So the first one says that the distribution is symmetrical. That means I can cut it in half and both sides look the same. That's not true. This side does this side does this. So that is not symmetrical. The second one says has a range of 25. So range, I have to go from one end to the other. So it goes from 5 to 45. That's a range of 40. Okay, so mentally all I did was 45 minus 5 to get 40. So that's incorrect. Cross that out. The distribution appears to have an outlier. So an outlier means all my data is kind of clustered together like this. But then you see this little guy over here, he's outside of that. He's outside of the cluster. That's what makes him an outlier. So that is true. That's why C is the answer. And the last one, let's see why it's wrong. The cluster goes from 25 to 30. So this cluster, this is where all they're clumped up together. It does not go from 25 to 35. It really goes from 20 to 45. So that's why that's not true. But it's also depending on you guys understand what a cluster is. And that's where all the data is clumped up. All right, let's look at the next one. A company ordered 10 box lunches from a deli for $74.50. Each box lunch costs the same amount. Which equation represents the proportional relationship between y, the cost of the box lunches, and x, the number of box lunches? Okay, so we have 10 lunches is equal to 74.50. And we want to write an equation where y is the total cost. So this is my total cost. That's my y. My 10 is how many is my variable, because sometimes I can buy 1 lunch, 12 lunches. That's where it's going to change up a little bit. But then if I wanted to know the total cost, let's see, what is my x then? The x is the number of boxed lunches. Oh, okay. It's right here. And that can change up. So x is how many lunches I actually get. All right. So now I need to write something about this. Can we figure out how much 1 lunch costs though? Like, let's actually look at this for a little bit. How much is 1 lunch? If 10 lunches are $74.50, 1 lunch is going to cost, and I can do this here, divided by 10, and you can probably already see it. 1 lunch costs $7.45. So this is fixed. This is never going to change. That's my constant. So I can represent this relationship as 745 times however many lunches I get is equal to how much I pay. That is my relationship. All right. So the other ones don't work because they're not really showing the proportional relationship. Like in 10, it's telling me that 7 for the cost of the food divided by how many lunches I get. That's not going to give me the cost. That doesn't help me there. With this one here, the reason I can't use this one is because each lunch does not cost $74.50. So I can't say each lunch. If that was the case, I wouldn't keep buying them. That would be a very high cost. And the one on the bottom also has a relationship where I have $74.50 divided by how much food I'm getting is equal to 10x. That doesn't make any sense either. All right, but you see how for this one I had to figure out which was what my y was first, that was easy. That was my total cost. I knew that. And I could only get my cost when I knew what the number of lunches and how much I was going to pay. But I had to figure out how much I was going to pay using some math. All right, hit pause and jot this down into your notes. Let's look at the answer for number 9. The answer is A. So let's look at why I kind of like the way this question's written. It's very interesting. We have Bob buying eggs and potatoes at the store. He pays a total of $25.92. He pays $2.57 for the eggs, and he buys 5 bags of potatoes for the same amount. All right, so we don't know how much this is going to be, but we know he buys 5 packs of them. So in this case, our unknown is the number of potatoes, and that's what we need to determine, the cost of potatoes, and which equation will show us that. And we know our total is $25.92, so that's going to be my y. All right, so look at how how we're gonna figure this out. Like normally, this would be written as this form: ax plus b equals c. So in this case, we know what c is. We know that altogether he spends $25.92, and he buys 5 packs of potatoes. We don't know how much that costs. That's why we're using x, plus $2.57 for potatoes. So if I wanted to get if I want my xb by itself, the first thing I have to deal with is this b, this number right here. And I want to take this out from this side, and I want to take it out from this side. Okay, so that means we're going to take $2.57 away from both sides. So I will subtract $2.57 here, and I will subtract $2.57 here. And I want that because this is going to create a 0 pair on this side and only leave me with 5x. On the other side, and I'm not going to solve the entire part out because that's not what the choices are telling me. I will do 2592 minus 257. Okay? And now I still want this x by itself. Now I'm only looking at this. Forget all this for a second. I'm only looking here. 5 times something gives me this. So the opposite of 5 times something is to divide. So instead I'm going to divide by 5. And on this side, divide by 5. So I would have x is equal to, and remember, I'm dividing all of this by 5. 2592 minus 257, all being divided by 5. And that's what you see here in A. Now what's tricky is that we're used to actually just solving this out. So let's say you went and you were just solving this. So you would do your first step, you will subtract 257, and you will get 5x is equal to 2592 minus 257. You'd get your 2335. And then we would divide both sides by 5. And we would get x is equal to 467. This is what we would normally want to do, and this will tell us how much one bag of potatoes is. But this problem wasn't asking us to determine that. They were asking which equation can be used to determine that. So that's where you'd have to look and say, well, what was the first thing I did? First thing I did was I subtracted 257. So you'd have to look to see in which of these do I subtract 257. Definitely A, not B. I'm not subtracting 257 here. I'm adding, and you didn't do that. So I would cross out B. And I will look at C and go, here I'm adding 257. We didn't do that, so I will cross that out. And so I would be stuck between A and D. And then after we subtract, we divide it. So here it was just an order of operations. I wanted to subtract first and then divide. But if I did order of operations, I would have to divide first and then subtract. So that's why that one is incorrect. So like I said, I actually like this problem because it's interesting. Because they're asking us to think in a different way, not just give an answer. But I get why it can be challenging. All right, hit pause and jot this down into your notes. Let's look at the answers for 10, 11, and 12. For 10, you have B. For 11, you have D. And for 12, you have B. All right, hit to the next chapter if you have these answers. If not, stay here. All right, let's go with number 10. Victoria has a movie subscription. I have many. She pays an annual membership fee of $24 and also a fee of $4 for every movie. So this is an annual fee, so that's every year. She does this one time. And then every time she watches a movie, she does 4. So that's telling me something here. Which inequality can be used to determine the total number of movies M she can watch if she wants to spend less than $100 a year? Okay, so I know she wants to spend less than $100. So I'm going to put this over here. And we know that every time she pays for a movie, she pays $4. So 4M plus the $24 fee. And so that's how I got my equation, 4M plus 24, not an equation, inequality. Wait, she wants to spend less than, ooh, look at that. She wants whatever she spends to be less than $100. So the 100 has to be more. So I had to flip that signal. See, this is why we have to be careful. That's the greater value, which is the $100. Okay, so here's my question. Can she spend exactly $100? Is that okay? Would that be all right? And I'm going to say no, because in the question it says she wants to spend less than. It does not say less than or equal to. It just says less than. So I'm not going to underline this. And that's why my answer is B. Okay, and that's why I'm not choosing C. All right, let's go to the next one. A regular price of shirts is $N. During a sale, the shirt is discounted by 15%. Okay, usually it's $N, but 15%. Which pair of expressions includes two correct ways to represent the price in dollars of the shirt? All right, so there are two ways we can think about this. So here's the shirt, N. Some kids go and they say, well, the shirt represents 100%. I only want a piece that I only want to know this part of it, 85% of the whole thing. So one way we can do that is to just find 85% of the shirt. So 85% times N. That's so I can find part of the shirt. Okay, so that's one way to find a part. Another way that some kids do is they take the shirt N and they go, well, I want to take away 15%. So they find out, well, how much is 15%? So what is 15% of N? And then they subtract it from the total. So a lot of kids do that. How much is the sale? Like, what is 15% of it? And then they go, so I'm going to take the whole price and I'm going to take away 15N. Okay? And when I look at my choices, which of them shows these two expressions? Well, in the first one, this is there. We have that. But here, this is missing an N. And you can see how close it is. Because it doesn't have an N, I got to mark it wrong. Because it's 85% of N. In the second one, I have the first part again. Oops. Notice even here it didn't have it. So this is okay. But here they still don't have that N. So I got to mark that wrong. For C, they're just doing whatever the price is minus $15. That's not okay. And the D is the only one that matches it exactly. N minus 0.15N and 0.85N. So you can see how if your attention is in any way divided, if you're rushing, if you're thinking about other things, how easy it is to miss little things. Like even me, I didn't even see at first that this didn't have an N. Like I had to look at it a second time and go, oh wait, this didn't have an N either. So you can see just how easy it is to have, if your attention is divided, to miss these little details, these small little details that can make a big difference. Okay, so make sure you're looking exactly for those two equations. Let's go to the next one. I want to know which decimal is equivalent to 7/12. And anytime I want to turn a fraction into a decimal, we're going to use division. We're going to do 7 divided by 12. Some kids can just read it from top to bottom, say 7 divided by 12, and you can use your calculator to do that. And here I got 0.583333333333, all those three. So I'm just going to put the bar over it. And the only one that matches that is B. It can't be A because you can see it didn't have that little bar. And the other two was if you had flipped it around the other way. So C and D is if you would have done 12 minus 7, which doesn't make any sense. All right, hit pause and jot this down into your notes. All right, let's move on to the next page. We have 13 and 14. The answers are B and C. Check off with your work and we'll break it down. With the first one, you want to know which expression is equivalent. So I want to make, again, I see this long expression and I want to find out which one would match something like this. And it looks like they've combined like terms to simplify it. So let's put in our equations, our expression. And I can see with both of these, I have to use the distributive property. So I'm going to multiply 3 and 6/10 times x, and 3 and 6/10 times 5. That's 18. plus 2 and 5/10 x plus 2 and 5/10 times 4 is 10. So I just did mental math because I know 4 quarters makes $1, so 250 4 times would make $10. Okay, from here, I want to combine like terms. So these two terms have the same variable, so I'm going to put them together. And now I have my constants together, and now I can simplify them. So for this one over here, I'm just going to add these two together. And 3 and 6/10 plus 2 and 5/10 is, oops, forgot my pen, 6 and 1/10 x. And negative 18 plus 10 would be negative 8. And it matches B. Let's go to the next one. A teacher, another box and whisker plot. They record test scores for students in class. The results are shown below. Based on the data, what is the interquartile range? So remember, that means when I'm looking at the box part, what is the distance from here to here? Okay, so with the first one here, that number is it looks like it's going by 1, so 65, 66, 67. And here, 75, 76, 77, 78. So what is the distance from 67 to 78? I can just subtract that and get 11. All right, hit pause and jot this down into your notes. All right, let's go to the next one. 15, 16, and 17. Our answers are D, C, and D. So check off. I did notice I had a little typo on mine with D, that I've had a 6. The denominator is 106 when I meant 105. So I apologize for that, and I didn't get enough time to fix it before this video. But let's jump in. All right. What is the value of the expression below? So again, I'm trying to simplify this expression. I'm going to give myself a ton of room. So I have 1/3 minus 2/3 plus 5/7 minus 2 and 1/5. Okay, so first I want to deal with what's inside the parentheses, and I have two fractions with different denominators. Matter of fact, all these fractions have different denominators. I have 3s, 7s, and 5s. So I want to find a common denominator for all of them. So I'm just going to do that now by just multiplying 3, 7, and 5. So 3 times 7 times 5 is going to be 105. So let's change all of these to 105. So the first one I had was 1/3. And let me clear out. 105 divided by 3. I would be multiplying by 35. So the first one is 35 out of 105. All right, then my second fraction was 2/3. So that's twice as many, so I have 70 out of 105. And with the next one, I have 5/7. So I'll do the same thing. 105 divided by 7 is 15, and 15 times 5 is 75. And the last one I have is 1/5. And that's 20. I know that one is 21 because 20 times 5 is 100. So 21 would make 105. Okay. So here we go. So now I have everything. They all look good. They all look the same. Now I can do the thing I want to do. I'm going to start by adding these two inside. 70 plus 75 is 145 over 105. And because they're both subtraction, I'm going to go from left to right. Let's do these first. And I have 35 minus 145, which is negative 110. And to subtract 2 and 21, I'm going to just change that to an improper fraction. So 2 times 105 is 210. 210 plus 21 is 231. So I'm just going to do it again just to check because I did all that in my head. So 2 times 105 is 210 plus 21 is 231. Alright, and here is my last step. I'm subtracting again, and I have negative 110 minus 231. I actually don't need my calculator for that one because I'm just going to make it more negative. So I have negative 341 out of 105. Okay, so now's the time where I have to actually bring that back to a mixed number. So it's definitely not A and B. It's going to be C or D. So how many 105s can I take out of 341? So if you did this on the calculator, you do 341 divided by 105. And I'm just paying attention to the whole number, 3. Okay, so that's the important part for me, 3. 3 times 105 is 315. So 341 minus 315 gives me 26. So my remainder is 26 out of 105, which is D. Alright, jot that one down into your notes. I want this space. And let's go to the next one. Which expression is equivalent? So it's another one to this long term 2 times. So let's just start typing it in. Alright, and I'm going to start by distributing first. So I have 2x plus 14. Awesome. Let's put the things that are together that are the same, are like terms next to each other. So 2x minus 18x plus 14 plus 4 fifths. And 2x minus 18x is negative 16x plus 14 and 4 fifths. I just combined them together. So definitely not A and B. So notice how for C and D, they both have improper fractions. So I'm just going to turn this to an improper fraction. 14 times 5 is 70 plus 4 is 74. There you go, 74 fifths. Alright, and for kids who are still struggling with how I got that, all I did was figure out if I had 14 whole numbers, 14 times 5, so I multiplied these two first to get 70, and then I added the other part. So I would have had 70 fifths plus 4 fifths, which is how I got 74 fifths. Okay, let's go down to the next one. I see a percent as I'm scanning. There are 2 movies shown at a theater. A total of 150 tickets were sold for the first movie. 40% more were sold for the second movie than the first. If each ticket costs $13.50, what is the total amount of ticket sales? Okay, so we know that the first movie sold 150 tickets. The second movie sold 40% more. So I don't want to know what 40% of 150 is. I actually want to know what 140% is. So I'm going to do 150 times 1.4. That's going to tell me the total number of tickets. Okay, so the second theater sold 210 tickets. And now I can figure out the total price for all of these. So 150 times 13.50 plus 210 times 13.50. Notice with both of them, I'm kind of doing the same thing. So why don't I just combine those together? Instead of doing it 2 different times, I'll just put them together, and that would make 360 tickets altogether. times 1350, because I just realized in looking at it, I'm multiplying by the same number, so I can really combine them. 360 times 1350 is $4,860. And there's D. Now, if you wanted to do them separately, you could. You could have done this one first and this one, and then just added them together. You still would have gotten 4,860. All right, hit pause and jot this down into your notes. Let's look at 18 and 19. Here's the reveal. B and C. Check off with your work. All right, let's start with 18. And the elevation at ground level is 0. An elevator starts at 90 feet below the ground level. After traveling 15 seconds, the elevator is 20 feet below ground level. Okay, so there's ground level. It starts at 90 feet below, and then it ends at 20 feet below. So that's important, because even the first time I did this, I thought it was 20 feet, and I just started writing, and I didn't even pay attention to the below. Which statement describes the rate of change for elevation in that 15 seconds? So, okay, so in 15 seconds, how far did it travel? It traveled from negative 90 to negative 20, so it traveled 70 feet. Remember, feet has to be positive. It can't travel negative feet. So it traveled 70 feet in 15 seconds. So if I want to find the unit rate, clearly I can just do 70 divided by 15. And that will be 4. 4 times 15 is 60. And my remainder will be 10. So I would have 4 and 10 out of 15 seconds. Okay, so just doing that, I know that C and A are completely wrong. I do notice that both of them have 2/3 because they did simplify to 4 and 2/3. So what's the difference between them? One of them says it traveled up, the other one said it traveled down. So think for a minute. How did the elevator go? And my elevator, I know, started at negative 90 and went up to negative 20. So that would make B the correct answer. Let's look at number 19. The original selling price of a stock was D dollars. That's the original price. The selling price for a share of the same stock at a later date was represented as 1.15 times 0.95D. Which description could explain what happened to the price of the stock? So let's think of this as changes in percents. And we know that 1 is equal to 100%. So in the inside of the story, it's down from 1 to 0.095. So it decreased 5%. It went down from 1 to 0.95. And then what happens here, again, 100% is 1. This is 115%. So that I know that it increased 15%. So how do I know which one happened first? Because what happens first is in the parentheses. So first this happens, decrease 5%, and then this happens, increase. Okay, so this is the first thing that happens. Here's the second thing that happens. So we said the first thing that happens is decrease 5%. So I could automatically get rid of B and D. The second thing that happens is it increased 15%, and that's C. Here it says it's decreasing by 0.15%, which is less than 1%. And that does what makes all the difference in the world. All right, hit pause and jot this down into your notes. All right, let's do the reveal for 20 and 21. Here we go. B and C. Check off with your work. Go to the next chapter if you have these two. If not, stay right here. We'll break it down. For number 20, Lance bought N notebooks. So we don't know how many. That cost 75 cents each. And some pens, P pens, that cost 55 cents each. And he paid 6.25% sales tax applied to total cost. Which expression could represent the total number he paid? Okay. So thinking about this, if I wanted to know how much just depends how much he spent on notebooks, I would do the notebooks times 75 cents. And then I would do the pens, because they're 55 cents, the pens times 55 cents. So right there I have 75 hundredths times N, and I have 55 hundredths times P. So I would add those two up together, because that's going to tell me how much I spent. Now, after I spend all this, I'm also going to add a sales tax to this. My sales tax is an increase of 6.25%. So if I want the total cost, I'm going to multiply this not by 6.25%, that's just the tax. I'm going to want to know, I would want to know the price of it, and then I would do this. So 1.0625 times the whole thing. That's if I want to do it in one step. Now, when I look at my choices here, my choices don't show that. So my choices show, so if that's not the case, what I could do is I can find, well, how much is the pens going to cost? Here's the pens and the notebooks. Plus, I want to know just the 6.25. So I would then just add on what the tax is. And I would have to do the tax of the same thing. And that's what's shown here in B. Actually, let me just circle this part here. Where here you see the cost, which is the pens and the notebooks, and here they just added the tax. Okay? The reason the other ones don't work in A, they're multiplying the tax times the number of pens. That doesn't make sense because we're taxing the amount, not the number of pens. In C, they're multiplying the cost times the tax. That doesn't make sense. And in the next one, they're doing the cost of each one separately times 1.06, and that just doesn't make any sense either. All right, let's go to the next one. I kind of like 20 because it showed how, like, even when I did my work the first time, when I checked to see, I didn't see my answer. So I thought, well, would be another way that this can be represented that is also equivalent. And that's what I had here, the cost plus the tax. All right, moving on to 21. We have a table with proportional relationship of x and y. We need an equation to represent this proportion. Okay, so like always, you could just take any of these, and we're looking at the relationship, and we know that y is going to be over on this side, and we usually have ax on the other side for the proportional, or because we talked about proportions in 7th grade, they call it kx. Okay, so what is the rate here? So k times 9 equals 225. That's what I'm seeing here. So if I wanted to know what that rate was, I can just divide both sides by 9 to figure out what k is. And k is just my constant rate of proportionality. So k is equal to 0.25 or 1/4. So in my equation kx equals y, I could have, or if I see the other way, they have y first, y equals kx. I know that in my scenario k, I know what that is, so it could be y is equal to 0.25x or y is equal to 1/4 x, which gives you that here. So that's one way that you can solve this. But you know, I like giving you other ways that can also be simplified. So what you could have also done is you could have taken your y and x and just figured out the rate. 2.25 over 9, and that still would have given you 0.24 or 1/4. And then you could have just used that to just plug into the equation. Okay, but the big key lever for this is you have to know the relationship for a proportional relationship. Proportional relationship, y equals kx. If it's more a proportion, some type of rate, and then something else, then I would use the other one with the ax plus b equals c. Okay, but I don't want to confuse us. So let's stop here and jot this down into your notes. Let's look at 22 and 23. The answers are D and D. So check off and stay here if you're ready for me to break it down. For 22, a farm grows 19 and 8/10 tons of wheat in 2013. The wheat output increases by 9.8% from 2013 to 2014 and by 5.1% from 2014 to 2015. Which expression could represent strategy for estimating the total output of the wheat in tons? All right, so let's tell the story about what happened. So here's 2013. The output was 19.8 tons. And then it increased 9.8%. So if I were to figure out how much this was in that year, and by 2014, I would do 19.8, and I would multiply it. I want to increase it by 9.8%. So I'm going to change it to a decimal by going whoop, whoop. I'm going to multiply it by 0.098. So that would be the first thing I would do. And then the story goes, and then it increased again by 5.1%. So in the next year, I multiplied again, and I want to increase 5%. So let's change it to a decimal 1, 2. So 0.051%. Okay, so that's what I would do to get all of this, to figure all this out. Now, remember, because I don't want only what an increase, I don't want just the increase. I want to know the total output. The total output. So then I need to know for the first year, what is 109.8%. So I have to change this to 19.8 times, move my decimal one time, 1, 2, 1.098. And then again, I want to know what the increase is, so I have to add the 5.1%. So I need 105.1%. So I'm going to multiply it by, move my decimal again, 1.051. Okay, so that's what's going on here. And then they added another twist where they said to estimate it. So they rounded all these numbers. So that's why they rounded the first one to 20 times 1.1% times, and they rounded this one up to 1. This one rounds down to 1.05%. And that's where we get it in D. Okay, so that's all they did. They got this, and then they made it extra tricky, and they said, well, you estimate it. So they just rounded all these numbers up. So here I rounded up to 20. This one rounds up and rounded up again to 1.1, and this one rounded down to 1.05. That's all they did. All right, let's look at the next one. At midnight, the temperature was -8. But at noon, the temperature was 23. So let's make a visual. I'm passing 0. So I was at -8 degrees, and then I went to positive 23 degrees. And I want to know what was the increase. So because, and I draw this out here with the 0 because I know that my distance is going to be more than 23. To just get from -8 to 0 is 8. And from 0 to 23 is 23. So I add these two together, and I get 31. Okay, so now they're asking, well, which expression represents that? So how could I have gotten to 31? So I need to find something that kind of showed the 8 plus the 23. And all they did here was like, which of these would give me a positive 31. Like if you were to do this work out, would you get positive 31? So you can actually try this yourself with your calculator. If you had negative 8 minus 23, you would get negative 31. So this one is wrong because I would get negative 31. We'll go to the next one, and now they're asking for absolute value of negative 8. That's what those two lines mean. So the absolute value of negative 8 is positive 8. So positive 8 minus 23, I already know I'm going to get a negative number. Negative 15. So, nope, that one doesn't make sense either. So we'll go to the next one, negative 8 minus the absolute value of 23. All right, 23 is already positive, so this is the same as negative 8 minus 23. That's not going to give me positive 31. It's just like the first one. And we'll do the bottom one. And again, they want the absolute value. So that means do what's inside there first. Okay, so we'll do what's inside, just like it was in the parentheses. Do that part first. So negative 8 minus 23, and we will get negative 31. And the absolute value of negative 31 is 31. All right, so it was a little trickier just because they used different expressions. But again, they're just asking which one can represent this. And I can just simplify the expressions and see which one matches what I know to be true. Okay? So hit pause and jot this down in your notes. And again, you might have other ways of doing these problems. Please share them in the comments because there is definitely more than one way. I'm exploring one or two ways, but if I explored every single way to do every single problem, this video would be way, way longer than it already is. Hit pause and jot this down into your notes, and please share your strategies and your questions. Let's look at 24. In this one, there's just one answer here. I'll reveal it in 3, 2, 1. The answer is B. So the question was, which point on the graph represents the unit rate? And the unit rate is when x equals 1. So you just have to find, here's x. So when x equals 1, what point do you have? And boom, you have it right here. When x equals 1, my y is 15. So that is my point. Oops, I circled the wrong one. There is my point, 115. It is, and that, I love that I just made that mistake because it is so common. I literally did this work and just switched the numbers in my mind, and I had to stop myself for a minute and go, that doesn't make sense. And so just make sure that sometimes your eyes move faster than your hand does, and so slow down your thinking. And I rushed right there because I thought this was just an easy problem, and I made the silliest mistake right now where I had the right answer in my work and I circled the wrong one. How many of us do that same mistake? How many of us make that same mistake where we do all the work, but because we rush just filling out our bubble sheets, we make a silly mistake. So don't make that silly mistake. Always look to just see, does that match what I put here? All right, check in your work, and if you had a different answer, make the change and add this to your notes. All right, let's get to 25 and 26. Day one is very long. There's so much stuff going on here with so many questions. All right, 25, the answer is A. And for 26, the answer is also A. Keep moving to the next chapter if you have them. If not, stay here for the breakdown. For the first one, we have a rhombus. That means that all sides are the same. When I see a rhombus, it just means a quadrilateral with equal sides. So every side is the same. The perimeter P of the rhombus is proportional to the length of each side. Which equation represents this relationship? So even though they're saying it's proportional, what do we know about the perimeter? If I wanted the perimeter and I know that every single side was S, I would represent this as P is equal to 4S. And that does represent a proportional relationship because I know that I'm multiplying my sides. I have to multiply by S to figure out what P is. So they're related to each other. P is equal to the product of my constant rate 4 times S. All right, and the one that is the most the easiest one. So C and D, they look pretty obviously not the right answer. But for B, you can see how it's saying the side is equal to 4 times the perimeter. So that's just, again, that's an easy place to, if you're rushing, to make an error. Let's go. Let's look at number 26 here. Pat uses 2 5/8 cups of sugar for 3.5 batches of cookies. She uses the same amount of sugar for every batch of cookies baked. How much sugar in cups per batch? Okay, does she use? So cups per batch, and she has 2 5/8 cups over 3.5 batches. So I want to find the unit rate. So I'm going to divide 2 5/8 divided by 3.5. Let's change these to improper fractions. With the first one, 8 times 2 is 16, plus 5 is 21/8, divided by 7/2. Let's put our reciprocals in. So I'm going to change it to a multiplication sentence. And 21 times 2 is 42. So now I have 42 over 56. So definitely C and D are wrong. And I just have to simplify this fraction. So I know a common factor. I can divide both of these numbers by 7. And I would get 6 out of 8. And I could simplify that even more to 3/4, which is my answer. So this is pretty cool question. They're just asking you to do unit rate, but with fractions. So we still know how to do that. We know how to divide, and you just had to use your fraction knowledge to divide fractions, and to simplify them to get your final answer. Hit pause and jot this down into your notes. Let's look at the answer for number 27. Here's the reveal. 3, 2, 1. It is D. All right, so let's go into it and break it down. What is the actual area in square meters of this field? Now, obviously, this is a scale drawing. This is one of the few geometry questions you're going to get, which are usually scale questions. And that means I have to actually look at the key for this problem, which tells me that each of the length of one side of a unit is 2 meters. So using that, I need to figure out what is the real area here. And I'm going to start by let's figure out the area. Sorry, that happened. Let's look at the dimensions we have so we can figure out the area. So 1/2 base times height for area. And the bottom of my field goes from 2 to 9, so that's 7 units. And the height of my field goes from 2 to 7, so that's 5 units. So area is equal to 1/2 my base 7 and my height 5. But here's the thing. We also know that for this one, it says that each of these is worth 2 meters. So then that means that this side here isn't 7, because it's really 2, 4, 6, 8, 10, 12, 14. And that's why the key is important. And on the other one, so instead of 5, it's 2 times that, so 10. All right, so we can multiply this out now. So I have 1/2 times 14 over 1 times 10, which is 140 over 2, which is 70. So that's one way. And in this way, I actually made the conversion here. But let's say I hadn't. Let's say I had done it as is first and then did change the scale. So what if I had 1/2 base height and I had 1/2 times 7 times 5? So I would have had 35 over 2. And if I would have had 35 divided by 2, I would have gotten 17.5. So that's the problem. If I had just used the number straight, I would have gotten this wrong answer. All right, so some kids I know wait and they decide to do the whole thing, and then they're like, well, I'll times it by 2 at the end. But that's not what the times 2 means when they're saying each side is 2 meters. All right, so I just wanted to make that distinction for you, so you can see the proper way to do it, as well as what a common error would be. Okay, hit pause and jot this down into your notes. And remember, you have to actually convert all the dimensions first before you apply any formulas. Let's look at 28 and 29. Let's do the reveal, B and C. So check off of your work. If you have these, move to the next chapter. If not, stay right here for the breakdown. For 28, a 7th grade ELA class. The teacher wants to order books for all her 7th grade students. He wants to determine the favorite book amongst the 7th grade students. So, all right, that I need to know. That he wants the favorite book of 7th grade students. What sample would be best? Now, for a sample, we want to have a fair sample, meaning without any bias. So as we look at these questions, as these choices, let's look if we can identify a bias in them. And a bias would change the result because of the sample itself. So let's look at the first one. If he only surveyed 7th grade girls. So there's a bias there because he'd have the opinion of girls, but he's not looking for only girls. He wants the entire 7th grade. So this would have a bias towards the girls and against the boys, because now boys don't have their perspective really shared. In the second one, he chooses every 5th student in the 7th grade. Now this one is the correct answer, and what's good about this is that it's very random. He's getting the population he wants, which is the 7th grade. That's the pop. And there's a point of being random by just counting every 5th student. So 1, 2, 3, 4, 5 students come out of the 5th student. He comes and he asks a question, and then he'll just ask another 5th student, another 5th student. This removes the bias because now it's not about him choosing a specific population, but it's about who's randomly walking by. And if the school happens to have more girls, they're probably going to be represented more in the sample. If there happen to be more boys, there'll probably be more representation in the sample. So let's look at the next one and see why it's a good but not the best choice. 1 out of 7 students in middle school. So again, there's a good random part to it where he's counting every 7th student, but notice he's not getting his prime population because he's asking every 6th, 7th, and 8th graders. And that's not what he's looking for. He's looking for information about 7th grade. So good. I love the randomness of 1 out of every 7 students, but the challenge was just that he was asking all middle school. Let's go to the next one. And the next one is if he asked all the boys in one of the classes. And this one absolutely has bias towards the boys. So he's biased in favor of boys, biased against the girls, because you're not getting a true representation of the whole class. And that's what you're looking for in a sample. You want a true representation that's really random, where it eliminates bias, where you can just get a true survey without any of your own biases in there. All right, let's do number 29. A 7th grade class sells gift cards at a fundraiser for the school library. Each gift card sells for $15. The library gets 35% of every card sold. How much money does the library get if the class sells 500 cards? Okay, so cards are $15 per card. They sell 500. And the library gets 35%. All right, so first, how could I represent this? I know I'm going to do 15 times 500 to get the cost of the card. And then I'm going to multiply this by 0.35 because I want 35% of that number. Okay, that's going to give me the number that I want. So let's start with what's in parentheses first. 15 times 500, which is 7,500, times 0.35, which is 35%. And I get $2,625. That is what the library makes, which is C. So again, just make sure you're paying close attention to the numbers. I'll admit, I did this problem wrong twice in a row because I wrote down the wrong numbers from the problem that was right in front of me, even though I highlighted it. So keep yourself organized. Make sure that you're copying down the right numbers and slow down your thinking if you feel yourself rushing, especially towards the end. We're at question 29. This is when you're going to start feeling like you want to rush. Let's hit pause and jot this down into your notes. Let's look at 30 and 31. The answer for 30 is A, and for 31 is B. So let's start off with breaking down 30, which is which graph represents the solution of the inequality 4 minus 4x is greater than 16. So remember, anytime I have an inequality and I want to find a solution set, I can solve it like an equation, except if I multiply or divide by a negative, I will flip the inequality symbol. It reverses. So that is the only difference between an inequality and working with an equation, right? So if this, let me start by just getting, I want a zero pair here because I want the x to be isolated. So I have to deal with that constant first. So 4 minus 4 gives me a zero pair. So now I have negative 4 is greater than 12. And now here's that condition I talked to you about where you're dividing by a negative 4. So I do have x, the negative 4 divided by negative 4 is 1, is less than negative 3. Okay, so just be careful with that. It's definitely not a positive 3 because I'm dividing by a negative. And how would I graph that? Here's negative 3, and I want x to be all the numbers that are less than 3. But I'm not including 3, so I would have an open circle, which is A. All right, so that's the one thing you do have to remember is that rule, that condition. Anytime you multiply or divide by a negative, when you have an inequality, your inequality symbol will change. Let's go to the next one. What is the value of the expression below? And they're all fractions. Okay, so let's be super careful with our fractions because not only are there fractions here, there are positive and negative integers that we're going to be dealing with. So we want to make sure that we're very careful with our rules and that as we rewrite our expressions that we don't forget any negative symbols. I tell you this because I did it the first time I did this problem. So just be careful that you are rewriting any negative symbols as well. All right, so I have negative 1 and a half plus parentheses negative 7/8 times negative 3/4. What order of operations we're going to do our multiplying first. So we're going to multiply these two numbers first. And so I get 21/7 times 3 is 21. 8 times 4 is 32. And because I have a negative times a negative, I know this will be a positive. Okay, so just be careful with that. So far we're so good. 21 over 32. And I have to add negative 1.5. Let's change this to an improper fraction. So negative 3/2 plus 21 over 32. We just need them to have like denominators. I like to, what do I want to change in this one? I'm going to use a method that I kind of like to use where I want to use the product of both of these denominators. So the product of 2 and 32 is going to be 64. Okay, and how am I going to change that? So I know that I multiplied 32 times 2, so I'm going to do the same thing to the top. 3 times 32. And that gives me negative 96. Aha! You see, I almost forgot this negative sign here. So I did 32 times negative 3, and that gave me 96. And then on the other side, I'm multiplying by 2 and by 2, and I get, on this side, 42. Positive 42. Okay? So, negative 96, no Siri, over 64. We're doing this on our own. We don't need Siri. Plus positive 42 over 64. I know my denominator is going to be 64. Negative, in case you need it, use your calculator just in case. Negative 96 plus 42 is negative 54. All right. So it's definitely a fractional one. So not C or D. But I do need to simplify it in simplest terms. And I can divide both 54 and 64 by 2. So 54 divided by 2 is 27. So negative 27, because it's negative 54 divided by 2. And 64 divided by 2 is 32, which is my answer. And that's B. Okay, so let's hit pause and jot this down into our notes. This would be the last question if it was just day 1. Stay on, and I'll also do the multiple choice for day 2. All right, here's the reveal for 32. C. So remember, this is the problem where you're probably feeling the most tired. You're at the end. You just want to finish. So this is a place where, again, a lot of kids may just rush through and miss small details. So slow ourselves down and let's take our time to work through it. Malika and Adrian prepared containers of potato salad at the deli. Each container was supposed to have a mass of 1 pound. The manager selected a random sample of containers prepared by each employee to check the mass of the containers. The results are shown in the table below. Which inference is best supported by these data? So that's a typo. It should be, turn around. It should be data, not dates. Okay, so we're going to look at all of these together. Let's see. Malika will produce more containers with a mass exactly 1 pound than Adrian will. Well, I'm looking at Malika's. She doesn't have any 1 pounds, and neither does Adrian. So I'm going to discount that one. That is not true. It's not supported by any of the evidence here. Let's look at the second one. Adrian will produce more containers with a mass of exactly 1 pound than Adrian will. Well, that's just the opposite thing. And again, neither one had 1 pound. So there's not any data to support that they're able to get exactly 1 pound. All right, C. Most of Malika's containers will have a mass closer to 1 pound than most of Adrian. So let's see if that's actually true. When I look at Malika's versus Adrian, well, Malika was closer. And then in the next sample, Malika was closer. And in the next sample, she was still closer to 1 pound. So this is way off. Here, Malika was closer to 1 pound. And Malika was closer to 1 pound. So in every single sample, Malika was closer to 1 pound than Adrian. So our data does support this. So C is the correct answer. And the reason why D doesn't work, most of Adrian's containers contain a mass closer to 1 pound. We saw that was not true. In every single one, Adrian was way more off than Malika was. All right, hit pause and jot this into your notes. All right, let's go into our multiple choice, day 2. So this is when you're most refreshed, starting in. Let's give the answers for 33 and 34, D and B. All right, let's start by eliminating, since we know what our answers are going to be. Let's start with number 33 and breaking it down. We want to know which situation results in a final value of 0. So in A, the total number of pencils that Aaron has, if he has 12 pencils and he bought 12 more. So when I think about this situation, he has 12, which I can represent with a positive number, and he's combining it with another 12. That is definitely not giving me a 0 pair, because they would both be positive in this context. So A doesn't work. The total number of blocks. So, okay, we're talking about numbers of blocks here that Tom walks. So automatically I'm thinking this isn't going to work because I can't have negative blocks walked. I can't undo the blocks that I walked. But let's keep going. So he walked 6 blocks north. So I would still count this as 6 blocks, so positive 6, and 6 blocks west. So that would still be a positive 6 and a positive 6, which also does not give me 0. So again, context matters. Let's look at the next one. The total distance that's hiked from the depth of 10 feet below sea level to 10 feet above sea level. Okay, so again, I'm talking about distance though. So I know that if I'm going from, I'm going to kind of draw this out. Actually, I should draw it the other way vertically. Let's do it vertically. And they're going from -10 all the way to +10. But my distance is still a positive number because I'm going a distance of 20 feet. So that doesn't work. So even though there was a context of a negative number that I could think of, this is about total distance, and distance can't be negative. And D, which we know already is the right answer, is the total number of cookies that Tiffany has. Is she bought 4 batches, so +4, and she sold 4 batches, which I can represent with a -4. That would give me a 0 because now she doesn't have any cookies. So that's why D is the answer. Number 34. Cheryl earns $23.75 babysitting for 2.5 hours. At this rate, how much does Cheryl earn for babysitting for 5 3/4 hours? Cool beans. So one, we could think of this as a rate problem. So how much is she getting per hour? So money over hours. So you could say she made $23.75 in, I'm going to change these to decimals for my sake, in 2.5 hours. So how much is she making per hour? I can just divide those. And so her rate is equal to $9.50 per hour. So if I want to know how much she makes after 5 3/4 hours, I could just do $9.50 times 5 7/500. So $9.50 times 5.75 gives us, and at first the number doesn't look great, but we round to the nearest penny because this is dollars, $54.63, which is our answer for B. So that's one way you can solve it, is to find the unit rate and then just multiply. Another way you could do it is by using a ratio table, which I am, of course, a big fan of. And you can put your rate in there, $23.75 and 2.5 hours. And we want to know how much she gets in 5 3/4 hours. For this one, you're creating an equation to be able to solve. So we're going to cross multiply. So if I multiplied this way, a number times 2.5, I get 2.5n. And then the other way, I'm multiplying, I'm going to have to use my calculator here, 23.75 times 5.75. And I get 136.5625. All right, so let me rewrite this equation. 136 and 5,625 10,000ths is equal to 2.5n. I'm going to divide both by 2.5. So let's divide this by 2.5. My answer divided by 2.5, and I still get 54,625, which we would round to 54.63. So either way will work. Use the one that works for you. If you like using the unit rate, if that made more sense to you, you can do that. If you're using the ratio tables and that makes a ton of sense for you, and you like the more algebra approach, go with that one. All right, hit pause and make any corrections to your notes that are necessary. Okay, let's look at 35. It's another stats problem. I can see a lot of dots here. And the answer for this one is B. All right, let's jump into it and break this one down. Whew, this one feels like a doozy. 2 line plots are shown below. The first one represents the average cell phone usage per day in minutes of 20 teenagers. The second one represents the average cell phone usage per day in 20 minutes for 20 adults. Which statement is true about the data sets is true? All right, so that means we're going to read them one at a time again and try to refute any claims. Like anything that we know is wrong, we're going to exit out. So we'll start with the first one. The mean of the data of the adults is larger than the mean of the data for the teenagers. So that means like the average for the adults would be higher than the average for kids. So let's just think about this for a minute. The adults, all their numbers go from 120 minutes to 360 minutes. For the kids, the teenagers, they're using the phone for, the lowest kid is more than the adults, 460 minutes to 620 minutes. So there's no way that the average is going to be higher for adults. The average is absolutely going to be higher for kids. So we can dispute that. That is not true. And you can see how this is tricky because it makes it seem like these are going to have the same values. They're both centered. But when I look at the ranges and where they're going from, it's totally different. So we had to pay attention to that one. Let's look at B. The mean of the data for teenagers is greater, which we know is true, than the mean of adults. Yes, because the scale for the teenagers has greater numbers than the scale for adults. Absolutely true, and that was the point that I was making, that we can see it in the values. The scale was different, so I already knew that the teenagers were going to have a higher average because their numbers were already in the 400s and higher, whereas the adults were only up to the 300s. So let's figure out why C and D don't work. For C, the range of the data, so now we're talking range, for the teenagers is greater than the range for the adults. All right, so let's see that. The teenagers goes from 460 to 620. So that range would be 160 for the teenagers. And the adults goes from 120 to 360. Nope, the teenagers have a greater range. So that part is true. So let's read the rest of it. Because the data points for the teenagers are clustered. Yet, this is the part that's false. The range has nothing to do with the cluster. The range is how spread out the data is. I see a cluster here, but that's still not changing my range of numbers. So again, they found one part that's true and one part that wasn't. And let's look at the last one. The range for teenagers is greater, which we know is true, than the range of the adults, because the scale has greater numbers than for adults. That doesn't make any sense. It has nothing to do with the scale. So the range was larger because it spanned out more numbers, but it had nothing to do with the scale. It had nothing to do with the cluster. It just had to do with the highest and lowest value. So B is correct because we were able to find the mean is greater, and it had to do with the scale of numbers. All right, hit pause and jot this down into your notes. Let's look at 36 and 37. 36 is B, 37 is C. All right, so check off with your work, and we'll start breaking it down. For 36, there are 140 students at the school. Of the students that are enrolled, 3/4 play sports. Of the students that play sports, 1/7 are in the art club. How many students both play sports and are in the art club? Okay, so we know we have 140 kids, and 3/4 play sports. So you want to know what is 3/4 of 140. You can change, if you wanted to change these both to fractions, you can do that. I'd much rather, because I'm working with a calculator, change this to a decimal. So instead of saying 3/4 of a number and multiplying by 140, I'm going to put 7/500 times 140. It really doesn't matter. You can use either one. So far this is 105. So 105 kids play sports. And then it says of these kids who play sports, which is 105, 1/7 are in the art club. Okay. So I want to know what is 1/7 of 105. So this one, if I change 1/7 into a decimal, I am going to get an irrational number. I could round it. But for this one, I'm going to decide, you know what? Fine, I'll keep the fraction. 105 over 1. And I get 105 divided by 7 and over 7, which I can do. 105 divided by 7, and I get 15. So 15 kids play sports and do art, which is B. Okay, and you can see how like my decision making, I'm very fluid in my math skills because I like to use the things that are most friendly for me. I could have just done all of this with fractions and worked all of it out. It wouldn't have mattered. I would have gotten the same answer. I still would get, if I was doing this part with fractions, I'm still going to get 105. I just chose doing it this way because I had use of a calculator as a benefit. But then when I had this fraction, I was like, yeah, that's not going to work as a decimal. So I was okay just working with fractions again. Again, doesn't matter. As long as you're still multiplying by that value, you're going to get the same answer. Let's go to the next one. Which expression is equivalent to this lovely expression right here? 17 times 1/3 x minus 7/2 x. All right, so we're going to start by just distributing. So I have 17/3 x minus 7/2 x. I do want my denominators to be the same. So I know that if what would make them the same here is if I had, and I'm going to just move this up a little bit. Is if both of these were a 6. Okay, so on this side, I'm going to multiply both of these by 2. And that gives me 34. 17 times 2 is 34. And on the other side, I'm multiplying these by 3. And I'm getting 21. So 34 over 6x minus 21 over 6x is equal to, I get 13 over 6x, which is C. And you can see how, like, I guess what was tricky for most people is they don't know where to put the x. In this case, I put it next to, but I've seen some people just write it right next to it, like, how do I put this? So if I have 17 over 3 times x, if this was a fraction, I would put the x over 1. So I would have 17x over 3. So some people do write it this way. Some people I've seen write it this way, the way I did. So if that helps, I hope that helps for you to actually see how you could actually write it. But my x is not in my denominator. It's definitely not. It's either on the side or it's up next to my numerator. All right, hit pause and jot this down. We are up to our last multiple choice question. Whew, we are up to the last one. Oh my God, this is one of the longest videos I've ever done on YouTube. But here we go. Here's number 38 for multiple choice. The answer is C. So let's jump into it and finish up this video. A store buys candy by the pound. The graph shown below represents the relationship between weight in pounds and total cost of the candy. What is the cost for 1 pound of candy? So they're giving us a 1 point, and we want to know this point over here when candy is 1 pound, but it's not exact. So I'm going to use this point to figure it out. And I want to know the cost per pound. Okay, so in this point here, it's telling me that 6 pounds is equal to $21. So if I want to find a unit rate, again, you could just divide 21 divided by 6. And there you go. 3.5 or $3.50. If you wanted to use a ratio table for this, you could, and you would get 6n is equal to 21, and you're still going to divide by 6, and you're again going to do 21 divided by 6, which is still going to give you 350. All right, and that's it. That's our last multiple choice question. This was a really long video. lots of little steps, but I'm pretty sure there were lots of questions that you already knew how to do, so you probably skipped over those. But just like with any other video, there are so many other ways that you can solve these problems. So please share if you have other ideas. If you have questions, share them as well. And also share if you like this video or if you found it frustrating. We're here to help you, and let me know what else you need in order to pass this 7th grade test. That's it for today. In the next video, we're going to break down the constructive response questions. So I hope to see you there. Be well, Math Marbles. Bye.